this question by labeling this diagram over here with the information given. So over here, D is 1.5 meters. We're given that Q1 has a charge of 3Q. Q2 has a charge of Q. Now this particle right here, we're going to call it Q3. So at what position X is the third bead in equilibrium? So to find this, the Coulomb force that both of these particles exert on one another will have to be in equilibrium for this to not move. So what we're going to do is we're going to set the Coulomb forces of charge 1 and charge 2 relative to charge 3 equal to one another. So we'll do K, Q1, Q3, and we'll take that distance and square it, and we'll set it equal to K, Q2, and Q3. Once again, we'll find that distance there. So let's start substituting in some values. So here we have K, Q1 is equal to 3Q, and Q3, we'll leave it as Q3 for now. And we divide that over, in this case, X squared. Over here, we're going to have K, and Q2 is simply Q, and once again, we'll leave Q3 as is. The separation distance, on the other hand, is this right over here. So to find that separation distance, we have to subtract out this part right here. So we could do 1.5 minus X, and we'll square that value. So we can go ahead and cancel out the K's on both sides, cancel out the third particle, and we can get rid of these Q's right here, leaving us with 3 over X squared is equal to 1 over 1.5 minus X squared. What we can do now is we can take the square root of both sides. So we'll get the square root of 3 divided by X. The square root of 1 is 1 divided by 1.5 minus X. Let's go ahead and cross multiply. So we get X is equal to 2.598 minus 1.73x. So we get 2.732. X is equal to 2.598. We solve for X and we get approximately 0.951 meters.